Welcome, everyone. I'm excited to kick off today's presentation. We'll be exploring the fascinating world of ocean life and scientific discovery. The title of our talk is From Far From Shore, an exploration of ocean life and scientific discovery. Over the next few minutes, we'll dive into some incredible marine ecosystems, learn about groundbreaking research, and uncover the mysteries hidden beneath the waves. Let's get started. The vast, unexplored ocean is truly one of the last frontiers on Earth. As you can see, most of our planet's surface is covered in water, which makes the ocean a massive part of our world. Interestingly, we've only explored a small fraction, less than 5%, of the entire ocean. That means there's still so much we don't know about what lies beneath the waves. Every year, thousands of new species are discovered in these uncharted waters, reminding us just how much biodiversity remains hidden beneath the surface. This enormous scope of the ocean highlights its importance and the need for continued exploration, especially as it relates to understanding our planet's ecosystems and the potential resources they hold. Coral reefs are truly remarkable ecosystems. Did you know that about 1/4 of all marine life calls a coral reef its home? That's a huge proportion, considering how vast our oceans are. These vibrant habitats are often called the rainforests of the sea because of their incredible diversity. In fact, coral reefs have the highest biodiversity of any ocean biome. They support thousands of species, from tiny fish to large predators and even plants. This incredible variety makes coral reefs vital not only for marine life, but also for the health of our entire planet. Understanding their importance helps us appreciate why protecting these ecosystems is so crucial for maintaining the balance of life in our oceans. Let's talk about life in the deepest depths of the ocean. One of the most fascinating aspects is the extreme size variation among these organisms. You'll find creatures that are as large as 4 feet, which is quite impressive given the environment they live in, but you'll also find tiny single-celled organisms. This huge range highlights how diverse life can be even in such extreme conditions. Now, a key feature of this deep-sea environment is the hydrothermal vents. These are essentially cracks in the planet's surface where hot, mineral-rich water escapes. These vents create completely unique ecosystems that are unlike anything on the surface. They support life forms that have adapted to thrive in these harsh, mineral-heavy waters. Speaking of adaptation, these organisms are remarkable. They can survive under extreme pressure, in total darkness, and in very high temperatures. Their ability to thrive in such conditions not only speaks to their resilience, but also helps us understand the incredible diversity of life and how it can adapt to almost any environment. All of this ties into the larger theme of how life persists and thrives in some of the most challenging places on Earth. So why do scientists explore the oceans? Well, first, understanding the ocean ecosystem as a whole is crucial. The ocean isn't just water. It's a complex, interconnected system that supports a vast diversity of life and influences our climate and weather patterns. By studying it, we get a clearer picture of how everything fits together. Next, learning about deep-sea animals and their natural history helps us uncover the mysteries of some of the most untouched environments on Earth. These creatures often have fascinating adaptations, and understanding them can inspire new technologies and even medical advances. Finally, monitoring the impact of human activities on marine life is more important than ever. Things like pollution, overfishing, and climate change threaten these ecosystems, and exploring the oceans allows us to assess these impacts and develop strategies to protect and preserve marine biodiversity for the future. All of these reasons connect directly to our overarching goal of understanding and safeguarding the ocean, which is vital for the health of our planet. Meet Sophie Webb. She is an ornithologist and a field biologist who specializes in studying birds and marine mammals around the world. Sophie's work takes her to many different ecosystems, helping us understand the complex relationships in these environments. Her mission, in this case, is a 4-month journey to the eastern tropical Pacific Ocean, aboard the NOAA research vessel McArthur II. This voyage is a crucial part of her research, allowing her to observe and gather data directly from the ocean. The main goal of this expedition is to study seabirds and marine mammals. But more specifically, Sophie is investigating why dolphin populations are declining despite the conservation efforts that are in place. This research is important because it helps us identify the challenges these animals face and guides us toward more effective solutions. Overall, Sophie's work exemplifies how dedicated scientists are working tirelessly to protect our oceans and the amazing creatures that call them home. This journey is a vital step toward understanding and addressing these complex environmental issues. On slide 7, let's take a closer look at the NOAA research vessel McArthur II and some of the key features that help us conduct our marine research effectively. First, we have the big eyes, which are powerful binoculars with 25-power magnification. These are essential for scanning the horizon to spot marine mammals and bird flocks from a distance, helping us track wildlife behavior and movements. Next, we have the computer stations. These are multiple workstations where our team can collect and analyze data on birds, marine mammals, and ocean conditions. They're crucial for turning raw observations into meaningful insights. Then there's the flying bridge, which is the highest deck on the ship. It's equipped with a shade canopy and observation equipment, providing an optimal vantage point for spotting wildlife while staying protected from the sun. Finally, the scientific labs, both wet and dry labs, allow us to process water samples and study ocean nutrients and plankton. These labs are vital for understanding the health of our oceans and the ecosystems within them. All these features work together to support our mission of studying and protecting marine life, making the McArthur II a truly versatile and essential research vessel. Let's talk about the threat to dolphins from tuna fishing, specifically through a method called purse seine fishing. In the eastern tropical Pacific, tuna and dolphins often swim together in large schools, which unfortunately makes dolphins vulnerable during fishing. Fishermen use these large nets called purse seines to surround and catch the tuna. The problem is, in the process, dolphins often get caught in these nets too. Looking at the impact, back in the past, tens of thousands of dolphins would drown each year because of this fishing method. This needless loss of life caused a huge public outcry in the 1970s as people became more aware of the issue and demanded change. In response, the Marine Mammal Protection Act was established. This law was created to protect dolphins and other marine mammals not only in U.S. waters, but also internationally. It marked an important step in addressing the problem and safeguarding these intelligent creatures from harmful fishing practices. Let's take a moment to look at some positive developments. As you can see, there has been a dramatic decline in the number of dolphins killed in tuna fisheries since the 1970s. This is a significant achievement, showing that efforts to protect these intelligent creatures are making a difference. Most tuna fishermen now follow improved practices, allowing dolphins to escape before they drown. Sometimes, swimmers are even involved in helping the dolphins to safety. It's encouraging to see these practical steps being implemented on the ground. Legal protections have also played a crucial role. Laws like the Marine Mammal Protection Act, along with international agreements, now provide a safeguard for dolphins worldwide. These legal measures are essential in ensuring long-term conservation. However, despite these successes, we still face ongoing challenges. Dolphin populations are not recovering as quickly as scientists had hoped. Researchers are actively investigating the reasons behind this slow recovery, which reminds us that conservation is an ongoing effort. Overall, while we've seen progress, the journey to fully protecting dolphin populations continues, and it's important to stay committed to understanding and addressing the remaining issues. The scientific investigation into dolphin populations is ongoing, and there are several key factors we need to consider. First, let's talk about capture stress. When dolphins get caught in nets, that stress can actually lower their survival rates. It's a serious concern because it impacts their ability to recover and thrive after such encounters. Next, overfishing plays a big role. When fish populations decline due to overfishing, it disrupts the entire food chain that dolphins depend on for food. This scarcity can lead to nutritional stress and affect their overall health. Pollution is another critical issue. Chemical pollutants in the ocean can harm dolphin health directly and also interfere with their reproduction, which could lead to long-term population declines. Finally, climate change is causing shifts in ocean temperature and currents. These changes affect marine ecosystems overall, influencing where fish and other prey are available. This can make it harder for dolphins to find the food they need to survive and reproduce successfully. All of these factors are interconnected, and understanding them helps us see the bigger picture of what's threatening dolphin populations today. Let's go through some practice questions to reinforce what we've learned. First, what is the main purpose of the author's journey to the eastern tropical Pacific? Think about whether it was to explore marine life, study ecosystems, or perhaps understand ocean currents. The key idea is understanding how such journeys help scientists gather data about the ocean and its inhabitants. Next, what are some of the tools and technologies scientists use to study the ocean? We often hear about satellites, underwater drones, and sonar. These tools allow us to observe hard-to-reach areas, track marine animals, and analyze ocean conditions in real time. They are essential for advancing our understanding of the complex marine environment. Now, why are coral reefs so important to the ocean ecosystem? Coral reefs serve as hubs of biodiversity. They support a vast number of marine species. Reefs also protect coastlines from erosion, provide food for millions of people, and contribute to the overall health of the ocean. Their well-being is directly tied to the health of the entire marine ecosystem. Finally, what is the connection between tuna fishing and dolphin populations? Historically, tuna fishing methods sometimes unintentionally caught dolphins, which raised concerns about dolphin populations. Today, many fishing practices have been modified to reduce bycatch, showing how human activities are interconnected with marine life conservation. Thinking about all these points helps us appreciate the complexity of ocean ecosystems and the importance of careful research and sustainable practices. Now let's look at some practice questions to deepen our understanding. First, how has the Marine Mammal Protection Act helped to protect dolphins? Well, this law has been crucial because it prohibits the harassment, hunting, capturing, or killing of marine mammals like dolphins. It also promotes research and conservation efforts to ensure these intelligent creatures thrive in their natural habitats. Next, what other laws protect marine life? There are several, such as the Endangered Species Act, which helps protect species at risk of extinction, and the Marine Protected Areas, which limit human activities in vital habitats. These laws work together to create a safety net for marine biodiversity. Moving on, what are some major challenges scientists face when studying the deep ocean and its creatures? One big challenge is the extreme environment. High pressure, cold temperatures, and darkness make exploration difficult. Additionally, the vastness and inaccessibility of the deep ocean mean that much of it remains unexplored, so gathering data is both costly and technically demanding. Now, why is it important to study the ocean ecosystem as a whole instead of focusing on just one species? Because every part of the ecosystem is interconnected. Changes to one species or habitat can ripple through the entire system, affecting the health of the whole ocean. Understanding these relationships helps us develop better conservation strategies. Finally, what actions can you take in your daily life to help protect our oceans and marine life? Small steps like reducing plastic use, avoiding products that harm marine species, supporting sustainable seafood choices, and spreading awareness can make a big difference. Every effort counts in preserving the health of our oceans for future generations.